What is this?
Alright, so let's take a look at our theorems and postulates for today. Now, it has all of our theorems and postulates for this unit. We today are going to be focusing on those first four. Okay? So postulates and theorems of angles formed by parallel lines. Like I said earlier, we're going to be focusing on parallel lines and what that means for us with their special angles. Alright, so before we start, let's go ahead and draw a little picture. Do you guys have a backside of yours? No. But you do have a little picture of L, M, and N, right?
Yeah.
Oh, how nice of you to mention. No?
Yeah.
Oh, but it's not labeled. Sorry. Okay. So you guys have this picture here.
Yes.
Here. Okay. Go ahead and fill in. This is line M, line N, and line O. You guys have those 1, 2, 3, 4, 5, 6, 7, 8. Who do we appreciate? Anyone that does math all day long.
I don't see my papers.
Alright, so we all have this picture, and we have labeled L, M, and N. Now, a lot of times when we label lines with just a letter, it's often cursive. Here, these two are print, obviously. Okay, so let's recap our different special angles. We have corresponding angles. I want you to turn and talk to your shoulder partner real quick and name just one pair of corresponding angles you see. Alright, bring it back to the front. Alright, 3, 2, 1. Back up front. What is one pair? I need a volunteer for one pair. Lucy?
1 and 5.
Do we agree with 1 and 5?
Yeah.
Job.
Alright, and what's another pair, Teresa?
2 and 6.
2 and 6. Another pair, Sam?
5 and 1.
5 and 1. Good. Same thing. Come on.
4 and 7.
4 and 7.
I was trying to see you.
And Will. 3 and 8. Okay, so these are my 4 sets of corresponding angles. Now, the definition of corresponding angles lets me look at this picture and classify these or identify them as corresponding angles. But notice in this picture we have parallel lines. This notation here indicates parallel. Okay, so if you want to go ahead and write that in, this means parallel. That means that line M and line N are parallel. Other notation you'll see for this is that I could say line, whoops. So M is parallel to N. This notation here also means parallel, which I like because in the word parallel are 2 L's that make that notation. That's pretty cool. Look, 2 next to each other.
Can I draw arrows on it?
If you want to, you can. Okay, so if you see this, that means that those 2 lines are parallel. If we see this notation on the picture itself, that means those 2 lines are parallel. Now, just like we had congruent segments, we would do 1 mark or 2 marks, and same thing with angles. If I had another set of lines parallel, I would then do 2 sets of arrows, or if there's another set, 3 sets of little arrows. Okay, so the ones go together, the 2s. Alright, so corresponding angles postulate. Remember, this is a postulate, and postulates or axioms are statements that cannot be proven, but they're accepted as true. They're so basic, so fundamental that we cannot prove it. But we look at it, we agree, yeah, that's true. It's just, we cannot prove it. So this first one is a postulate. You'll notice the other 3 are theorems. Those are the ones we can prove. And we might be doing that at some point in time. You might be asked to that homework. You might be asked to do it on a quiz or test. Alright, Now, before we reveal what the postulate says, I want you to highlight or circle or star, do something to make that word parallel stand out to you. You can highlight, you can just use a different color, you can put a big circle around it, put a big star, something to make that stand out to you. Because these postulates and theorems only hold true when the lines are parallel. Alright? If the lines are not parallel, I cannot use these postulates and theorems. So for our first one, corresponding angles postulate, we've identified our corresponding angles. Let's talk about what that says. Let's go here. Alright, corresponding angles postulate. If a transversal intersects two parallel lines. Alright, so start off with that phrase. If a transversal intersects two parallel lines. So all that's saying is we have two lines that get cut, two parallel lines that gets cut by another one, or transversal. Alright, so it's an if then. What type of statement is that? Conditional statement. Alright. If a transversal intersects two parallel lines, then the corresponding angles are congruent. If a transversal intersects two parallel lines, then corresponding angles are congruent. So let's take a look what that means for a picture. We said 1 and 5 are corresponding, so I could say that 1 and 5 are congruent. Do they look congruent to you?
Yes.
Yeah. And if we talk about this non-mathematically, we see that parallel lines are at the same slant, if you would, or kind of at the same slope. And so when your transversal intersects them, it's going to intersect them at that same angle. Now, again, we cannot prove this because it's such a basic idea, but we agree that this is true. We can see that since they're parallel, they're going to have that same slant, that same slope. The line cutting through it will intersect them with that same angle. Okay? So we can say the same for 2 and 6 are congruent, 3 and 8 are congruent, 4 and 7 are congruent. Alright, so that's corresponding angles. If my lines are parallel and we have that transversal, all my corresponding angle pairs are congruent. So be careful, 1 and 5 are congruent, 2 and 6 are congruent, but they're not all 4 congruent to each other. Okay, they're separate pairs. Same
Wait,
difference.
so 1 and 4 aren't congruent?
No. What type of angles are 1 and 4 actually? Supplementary. They're linear pairs, so no, they're supplementary. We could have them be congruent in a particular case. What would they have to be if they are congruent? Right angles, yeah. But aside from that, we don't know they are. Come on.
The figure also forms vertical.
Yes, and we'll talk about how vertical angles helps us out later on. Yeah, Lucy, do you have a question?
Yeah. Can you have corresponding angles if the ones aren't parallel?
Yes, you still have corresponding angles, just they aren't going to be congruent. Yep. So it's a good distinction Lucy asked about this. We can still have corresponding angles if my lines aren't parallel, but once they're parallel, we know that those are. Other questions on that? Those are good questions. Okay. So alternate interior angles there. So now let's take a look at. Hold on. Let me be particular for just a moment here. Okay, so now let's talk about alternate interior angles. Let's first just identify them. So real quick with your shoulder partner, tell your shoulder partner what pairs are alternate interior pairs.
Okay.
Alright, go ahead and bring it back up front. Who feels brave enough to give me one pair?
Asia knows.
What? I don't know.
So Shannon, did you volunteer this time?
No, I think Asia did.
Shannon, give me a pair.
4 and 6.
4 and 6, do we agree?
Yeah.
Alright, angle 4 and angle 6, and then William, go ahead and give us another 3 and 5.
There's another one?
Alright, do we agree with those two pairs?
Yeah.
Okay. So we have 4 and 6. They're in between, that's my interior. They're opposite sides, so alternate. And then 3 and 5. Alright. So for this one, we're going to start off the same way as I did for corresponding angles postulate. If a transversal intersects two parallel lines, I'll let you guys catch up since you actually have to write it out. I did. If a transversal intersects two parallel lines, then alternate interior angles are, and I want to discuss with your shoulder partner what you think they're going to be. Alternate interior angles are, and I want you to discuss with your partner what you think.
You're going to be opposite. So there's two other
Alright, let's bring it back up front. What do we think? Alternate interior angles are? Congruent, do we agree?
Yes.
Ow! Good, congruent. And we'll talk about this in just a moment. I want to make sure we all have this down. So alternate interior angles are congruent. So we would then have that 4 and 6 are congruent. And likewise 3 and 5. Okay. Alright, now let's talk about how we can conclude that. So if I have, let's start off by using my corresponding angles postulate. That's basic, right? That's foundational, it's fundamental, our starting blocks. If I have 1 and 5 are congruent, what do I know about 1 and 4? They're supplementary. They're supplementary by that linear pair postulate. What do I know about 5 and 6? They're supplementary by the linear pair postulate. This is another situation in which the congruent supplements theorem helps us out. Because if I have 1 and 5 are congruent, and I have, so angle 1 is congruent to angle 5, and I have angle 1 and angle 4 are sup, and likewise, angle 5 and angle 6 are sup. Who remembers what the congruent supplements theorem says? Lucy?
If one angle is supplementary to an angle, and another angle is supplementary to the same angle, and those angles are congruent.
Beautiful. Two angles supplementary to the same angle are congruent. Now, right now, I don't have the same angle, but since these are the same, I could take 1 and replace that for 5 here. So then I have angle 4 and angle 6 are supplementary to the same angle. Then I can say angle 4 is congruent to angle 6. Now we've talked about how we can go through and formally show that, right? Say measure of angle 1 plus measure of angle 4 equals 180. Same thing here, substitute, simplify, and show that. But using that theorem helps us to get there. So using linear pair postulate, mixed with substitution and congruent supplements theorem, we can prove that that theorem is true. We can prove that alternate interior angles are congruent. Emma?
When you're writing your proofs, do you have to show the step where you're substituting angle 5 for angle 1, or can you just go straight into saying angle 4 is congruent or supplementary to angle 6?
You could go ahead and state this. Technically, we should have a little step beforehand, but once you've identified them as congruent, you're good to go ahead and substitute it. Yeah. So you would have to state this first, and then you need a separate step that says angle 1 and angle 6 are sub. And your reasoning for that would be substitution. Does that make sense? So you have to first state them without it, then substitute them. When you substitute, your reasoning will be substitution. All right, other questions with that? Okay. So now let's take a look at, actually let's go to alternate exterior angles.
Oh, I actually know these ones.
Alright, alternate exterior angles. I want you to discuss with the person behind or in front of you. You talk to your shoulder partner today. And list alternate exterior angles. Alright, go ahead and bring it back up front. Alright, volunteer for one pair.
No,
Amani?
1 and 8. 2 and 7.
2 and 7. Very good. And another pair? Okay.
1 and 8.
1 and 8. Do we have any others?
8 has
Do we agree with those two sets?
7 and 2.
7 and 2? Oh, gee, we already have that, don't we? 2 and 7, same thing as 7 and 2. Alright. Do we have questions with those? Alright. Now, this one might be a little bit harder to see. Quiet down. This one might be a little bit harder to see because they're further away, but I want you to discuss with that same person what you think those are going to be. Alright, go ahead and bring it back up front. Copy down that part, the conditional part. If the transversal intersects two parallel lines, so same conditional. If a transversal intersects two parallel lines, then alternate exterior angles are, what do you guys think? Congruent. Do we think congruent for this?
I do.
Are congruent. That is indeed correct.
Yeah.
So then alternate exterior angles are congruent. And we'll take a look at why this is. Because again, you might be asked to prove this on a quiz or test. Maybe for your homework. Maybe in class. You never know. Alright, once you've got that copy down, go and look up at these so I know we're all on the same page. Okay. So, again, a theorem can be proven using definitions, vocab, but also previous postulates or theorems. So if I look here, alternate exterior angles, we said 2 and 7, 1 and 8. So I'm going to go ahead and do 2 and 7 since I don't have any markings on these. Now, if I first think of my corresponding angles postulate, I have 1 and 5 are congruent. Don't we have that same thing? 2 and 1 are linear pairs, thus supplementary. 5 and 7 are linear pairs, thus supplementary. So we could do what we just did to prove that. Also, if they let us use alternate interior angles, we know that 4 and 6 are congruent. what do we know about 2 and 4?
Vertical.
They're vertical angles, thus they're congruent, and likewise with 6 and 7. So you could use that theorem first and then some substitution against there, or transfer that. All right, questions so far before we do our last one? Okay. Now, same side, interior, not interiors. Okay. Same side, interior angles theorem. What was another word we used instead of same side? Consecutive. Okay, so consecutive and same side mean the same thing. You can use either phrase. I don't care which one you use. Maybe it will recognize either phrase. They're used interchangeably there. Alright. So consecutive for same side interior angles there. Let's first identify our same side interior angles. This one I think you guys can handle on your own. Who can give me a pair of the same side interior? Lucy?
4 and 5.
Okay, so we have angle 4 and angle 5. And then what's my other pair, Teresa?
3 and 6.
Good. Angle 3 and angle 6. So again, remember interior is in between my 2 lines that are getting cut, and same side, opposite, it's been the same side. Okay, so let's again rewrite that first part of my conditional. If the transversal intersects 2 parallel lines, if a transversal intersects 2 parallel lines, then same side interior angles same side interior angles are. And now I want you to turn and talk with someone you haven't talked with yet.
Is every single angle line?
I can't tell you the answer.
So yes.
Alright, go ahead and bring it back up front.
I tried to get her to bite.
Sam. Now I want you to quickly share with your shoulder partner what you and your partner came up with. Alright, bring it back up front again. Now, I've heard the word congruent, so raise your hand if you think they're congruent. We had some stuff about the baby. Alright, so if we're not thinking congruent, what else are we thinking, Teresa?
I think they're supplementary because 1 and 4 are supplementary. 1 and 5 are congruent, so then 4 and 5 will be supplementary.
So raise your hand if you think supplementary.
Okay.
Okay. Anybody think anything other than congruent or supplementary? Supplementary is correct.
Yes.
Supplementary.
I supplement. Yeah, and go to another one. It would not be congruent.
Next time I'm going to go in a different order.
No.
Alright, so these are supplementary. What Teresa said is spot on. We know that 1 and 5 are congruent. How do we know that?
Because, yeah, corresponding
angles postulate. Thank you, Cameron. Not just because they're corresponding angles, but because the corresponding angles postulate. Man, you guys are good. Alright, tells us that. So we know 1 and 5 are congruent. But we also know that 1 and 4 are supplementary. So using substitution, I could say 5 and Very good. Very good. Okay. So now we could go through and change these. These would all be congruent here, congruent, supplementary. Yes.
If you were writing out a proof, wouldn't you have to go through the whole thing of saying 1 and 4, like the definition of linear pairs and then linear pairs?
So we're at the point where I trust you can look at the picture, identify their linear pairs, and just go and say 1 and 4 are supplementary by linear pair postulate. So likewise, I trust you can look. Go away.
It's red.
Oh, because the smart board decided to reject us. Okay, that's all right. It's happened before.
Board is not the only one.
I don't get it.
All right. So Amon, I trust also that you guys can look at this and say 1 and 5 are corresponding angles, and then directly say 1 and 5 are congruent by corresponding angles postulate. Okay, so Amon asked a good question. We're past the point now of making you identify it before using it. I trust you can go ahead and look at the picture, identify it, and use the postulates accordingly. Okay. Now, let's talk about some notation for this. These postulates and theorems are kind of long, right? But thankfully they do have names. So we can call them by their name. If you ever forget what the name is, just state what the theorem tells us. Now, the names themselves are pretty long though. So you can abbreviate, but you do need to have all the pieces. So for corresponding angles postulate, you could go ahead and abbreviate this as corresponding angles. Okay? But notice you must have all 3 pieces. Sam put it away. So I have corresponding, I've abbreviated. You can just use the angles notation, that's fine. But you do have corresponding angles postulate. If you just say corresponding postulate, corresponding what? If you just say corresponding angles, you're not using the postulate. Okay? So you need to have all those 3 pieces. Now you can kind of see here alternate into your angles theorem, so you can abbreviate that way. Same side into your angles theorem. And then alternate exterior angles there. So yes, there are a lot of pieces, but I will be very strict. If you don't have a piece, you get it wrong. Come on.
Is there like a main difference between postulates and theorems, or are they just different words for the same thing?
No, postulates cannot be proven, so it's so basic that we cannot prove them. They're accepted as true though. Theorems, we can prove those using previous postulates and theorems. Yeah. But they're both statements that are true about the information. Postulates are like the starting blocks, theorems are the building blocks. Other questions with those? Okay, so you need to add this to your memory because we will be using these to justify and support and in our proofs. So now let's take a look at how we can actually use these and apply them to problems. So again, today we're doing just these first 4. Next class, we're going to talk about the converse of these. Because we know if the conditional is true, is the converse necessarily true? No. So that's what we're going to investigate. Is the converse true or not? So if the conditional is true, what's the other one that's true? Contrapositive, good. So next class, we're going to take a look at the converse and see if those are true and what that means for us. All right. And then we'll continue through. So don't lose this piece of paper. Keep bringing it back from class to class. Now let's take a look at actually using what do you want to
You just put 10.
No, I didn't.
Like 1,
Alright, is there anyone that did not get this sheet that says notes 1, notes and examples? We're good here? Okay. So now let's take a look at this. This is using our postulates and theorems that we just learned. All right. Now up here at the top, they've just gone ahead and recapped for you what those theorems and postulates say. Again, you can call them by their name. And again, key thing, we have to have the lines were parallel when they got that. Okay, so let's take a look at number 1. It says identify all the numbered angles that are congruent to a given angle and justify your answers. So for number 1 here, we're taking a look at this angle that's 132 degrees, and they want us to identify what other angles are congruent. So let's just go ahead and work through the postulates and theorems we learned today. We know that if the lines are parallel, then the corresponding angles are congruent. Do we have parallel lines within my picture?
Yeah.
Yes, we see that little notation here. Okay, so we know that those two are parallel. All right, so then any set of corresponding angles corresponding to 132 is going to be congruent. What angle is corresponding with 132? Lucy?
5.
Okay. So we know angle 5 is congruent, so identify all numbered angles that are congruent. And what's my justification? What did we use? Corresponding angles postulate. Good. Corresponding angles postulate. Let's set up. So we've got 132 and 5. Okay. So we've done corresponding angles. Now we also know that alternate exterior are congruent. Do we have one that's alternate exterior with it?
Yes.
Which one? Good. Angle 7. So we have angle 7 is also congruent to 132. And we use alternate exterior angles here. Now, we also know that alternate interior angles are congruent. Do we have any alternate interior angles with that 132? Why not?
It's exterior.
Yeah, it's an exterior. It's not even an interior, so we can't have an alternate with it if it's not an interior. Come on.
But isn't 3 again? Never mind.
Okay. I think you're on the track to thinking of our last one, so keep thinking down that road. Okay?
I was gonna say like 3, isn't that the vertical angle in real?
Good, good, good. So we can also classify the angle 3 by vertical angles theory. We know that angle 3 is congruent because that's vertical angles with it. Vertical angles theorem tells us vertical angles are congruent. And then over here, same side interior, those ones are supplementary. Well, it's not even interior, so we can't use it anyway, and it's supplementary, so it doesn't help us out. You might have also thought, well, hey, 3 and 7 are corresponding, and if that's the same, then those must be the same. Or 3 and 5 are alternate interiors, so if that's the same. That's true, but its relationship with 132 is actually what it was there. Okay? So we know that these 3 are congruent with 132 by vertical angle theorem. So only having this angle would actually allow us to solve for all of these other values here. So, questions on that one? Okay. So let's take a look at this next chunk. The 5, 6, 7, and 8. So it says find measure of angle 1 and measure of angle 2, and then justify each answer. So let's go take a look at just number 5 here. So find measure of angle 1 and measure of angle 2. So we need to actually have some numbers with it. Whereas before we were just identifying what was congruent. But we're still justifying. Make sure you read and follow all directions. Alright. Let's start off with, okay, let me go ahead and highlight this here. So we have our 130 degrees. What is angle 1 in relationship to this guy? Good, supplementary. So what's going to be the measure of angle 1? 50. So we know that measure of angle 1 is 50 degrees, and we used our linear pair postulate. Because linear pair postulate is what lets me know that those are supplementary, and then our definition is what lets me add two things. So a definition of supplementary. The big idea being linear pair postulate. Okay, so we've got angle 1. 50 degrees. What's going to be the measure of angle 2?
130.
Now, how did we know 130? Good. Corresponding angles postulate lets me know that the corresponding angles are congruent, which means their measures are equal. Now, if this were an proof, after using corresponding angles postulate to state that these are congruent, then you'd have to convert it to measures equal, remember? So notice my postulates and theorems we learned today only tells us congruent or supplementary. If we need to change it to measures equal, we have to use that definition of congruent. Alright, questions on that chunk? Let's take a look at this next piece down here, the bottom part of our page. And it says find the value of x and y, then find the measure of each labeled angle. Let's take a look at number 10 over here. Alright, so now we have some variables that they want us to solve for. So we still have to use these postulates and theorems to solve for these unknown variables. Now, 10 is a pretty skinny, itty-bitty picture. If it helps you, feel free to extend out the lines or to even redraw the picture if you need to. I'm going to go and redraw it off to the side because it's kind of hard to see otherwise. So they said that these were parallel, and they said that this guy is x over 2, and that this pumpkin one is 6. Okay, so anytime if you need to redraw the picture because it's too small or too close to it, feel free to do so. And again, if it helps you just to simply extend out those lines, that's perfectly fine. Now, we also had this line cutting through. Does that make any difference on our picture though? No, because my angles aren't along that transversal. That transversal isn't parallel to anything, so it doesn't make a difference for us. Okay, so now we've got these as my parallel lines. What types of angles are x over 2 and 7x? Which are my special categories?
Corresponding interior.
Same side interior, consecutive interior. Good. We see it's in between those parallel lines, so this is my interior, and they're on the same side. What does the theorem tell us about consecutive interior angles?
They're supplementary.
Good, they're supplementary. So we can go and set up our equation. X over 2 plus 7x equals 180. Now, sure, we could go ahead and combine those together. We'd have to get a common denominator. We can certainly do that. But probably a little bit faster is just going to be simply to get rid of that denominator too. How do I get rid of a denominator? Go ahead, Mom. Let's multiply by that denominator on both sides. Now be careful, I'm still seeing this mistake from you guys, this algebraic mistake. This must be distributed to both pieces. Don't forget to distribute it. So then I have x plus 14x equals 360. I want to make sure we're good there. Does anyone not understand what I just did with that piece? I'm going to go more in depth with it. Okay? So now we've got x plus 14x, so that's 15x equals 360. And we want to divide by 15, but we don't use our calculators in here, so let's think about how we can work smarter, not harder, to get our answer. Alright. 360 divided by 15. I wouldn't expect you to know this just from memory, so let's reason through it. We know 15 has 3 and 5 as factors. Is 360 divisible by 5? Is 360 divisible by 10?
Yes.
Yes, so if it's divisible by 10, it must be divisible by 5, because 5 is a factor of 10. Is 360 divisible by 3?
Yeah.
Yeah, so you can go either way, whichever one you feel more comfortable with. I'm going to go ahead and use 5. Okay. So let's go ahead and reduce the bottom by 5. 15 divided by 5? 3. Now let's divide the top by 5. I want to kind of show you guys how you can do a little bit of mental math. Yeah, you can definitely do this off to the side. Let's do a little bit of mental math. How many times does 5 go into 36?
A lot.
7. And we had 1 left over. So then how many times does 5 go into 10? 2. So it's actually 72 over 3. But can we simplify that even more? Oh, I think we can. How many times does 3 go into 7? How many times does 3 go into 7? 2. And we had 1 left over, so 3 goes into 12. 4 times.
Wow.
So 24. That allows us to do larger numbers a little bit easier. Now again, we could have divided this by 3 instead. I could have done 360 over 15. If I would have divided by 3 on both top and bottom, if I would have reduced it by 3, how many times does 3 go into 36? 12. So it would be 120 rather than just 12. And 3 goes into 15 5 times, and then you can do the same thing. 5 goes into 12 2 times, we have 2 left over, 5 goes into 24. Okay? So those are some things you can do to kind of make it a little bit easier for yourself. Alright, so x is 24. Am I done?
No.
Oh, what else did I have to do?
Plug in x.
Yeah, I have to find x, y, and then find the measure of each labeled angle. Remember in geometry, they love to ask for more. You're out of algebra land, they're always going to ask for more now. So if I take 24, let's do it with this guy. If I take 24, put it back in, what do I get?
12.
If I take 24 and put it back in here, if you struggle with doing this mental math, what is 7 times 20? 140. 7 times 2 is just 14, so 7 times 20 is 140. And what's 7 times 4?
28.
So then 7 times 24 is 168. What could I have done instead of substituting it back in here? Good. So as Amy said, take 180 minus 12, right? We know it's supplementary. So if you already have your 12, then subtract that from 180 and get 160. Either way, multiple ways to get there. Amani, did you have a question?
No, I was going to say that.
Okay. Alright. So we have x we solved for, and then we solved for our angles themselves. Okay, so a little bit more work for you. You gotta first figure out which thermal postulate can I use, how can I use it to set up an equation.
I'm not sure how it's corresponding.
They're not corresponding, they're same side interior.
Oh, okay.
Consecutive interior. I prefer this. Alright, remember with corresponding one needs to be the exterior, one needs to be interior. Almost. Alright, any other questions on this? Okay. Now what I'm going to have you do is I'm actually going to pair you up with someone in class, different than your shoulder partner because you've been talking to them all day long. And you're going to work on the front side of the paper together. So I'm going to first pair you up, and then you'll actually pick up your stuff and move around the classroom, okay? Sam, you can go to the front. So pack up your stuff, and then I'll get you guys paired up, and then we'll go ahead and take care of Alright, so on the back side, problem 13 with the 2-column proof. Now they give us 2 sets of parallel lines for this. So they say that A is parallel to B. Let's go ahead and mark that in. And then they say that X and Y are parallel. So when we mark that in, we're going to use 2 little arrows because those go together and then the ones go together. Now, of course, that's going to be our first statement. A is parallel to B, and X is parallel to Y. That is going to be given to us. But let's take a look at what we're wanting to accomplish. We want to show that angle 4 is supplementary to angle 15. Notice that these are not on the same transversal by any means, which means we need to somehow get them to connect together. Now we've got a variety of options here. If I go along my transversal A, I know that 4 and 8 are congruent. And if I then look between 8 and 15 here, I don't have a special angle relationship, but I know that 5 and 13 are congruent and 8 and 3 are supplementary. Or likewise, I could say 15 and 7 are congruent, but 8 and 7 are supplementary, and then do some substitution there. So you could go along that way, or we could head down this direction, say 4 and 12 are congruent, and then we could again do 12 and 16 are congruent, those are supplementary, something along those lines. So when you go through and do this one, you might have a different answer than the person next to you. And we see that with proofs. Sometimes we have slightly different answers because you go about it slightly differently. Let's go ahead to connect these two lines together. First, we want to get these connected somehow so that I can connect these two lines. So I'm going to connect these two and then connect from it. Okay? So let's start off. I'm just going to go with 4 and 8 are congruent. So angle 4 is congruent to angle 8. And what's my reasoning for that?
Corresponding angles.
Corresponding angles.
Postulate.
Postulate. Corresponding angles postulate. Good. So now I've connected the two transversals that 4 and 15 are on. Right? Now I've got 8 along that same transversal, but now we need to connect those somehow. Now, again, we said that we could go and say 15 and 13 are congruent and then show that those are supplementary. Or I could say 15 and 7 are congruent and then show that those are supplementary. What would be my reasoning for 15 and 7? Again, corresponding, since I'm already using that, I'm just going to go ahead and go that route, so it's one less thing I have to write. So we can go and say angle 15 is congruent to angle 7. Again, that same reason. So I'm just going to go and put that together in one step there. Corresponding angles postulate. Okay, so I have 15 is congruent to 7. Alright, then what can I say about 7 and 8? Good, they're supplementary. Now I'm going to look ahead. I'm trying to say angle 4 is supplementary to angle 15. So I'm going to set up my sentence in the same way. And let's see, we know that 8 and 4 are the same, so I'm going to start off with angle 8. Angle 8 is supplementary. Angle 8 is supplementary to angle 15. And again, I looked ahead to save myself some time and effort to kind of get it to match up there. All right, what's my reasoning for 8 and 7 being supplementary? Definition supplementary lets me say that if they're supplementary, that means it's linear pair postulate. Good. Linear pair postulate lets me say, hey, those are linear pairs. I know that means they're supplementary. All right, linear pair postulate. Now our final piece, we want 4 and 15. I said angle 15. It's 8 and 7, right? Whoops. I'm ahead of myself here. So I have 8 and 7, I want 4 and 15. But what do I know about 4 and 8? They're congruent, so I can just say, instead of angle 8, angle 4. And then what do I know about 7 and 15? They're congruent, so I can say angle 15 is correct. Notice again how that saved me some time, because now I have it matched up perfectly. What is my reasoning there? Substitution. Okay. Again, yours might have looked differently if you did it before or whatever. Now your homework for tonight is just textbook homework, but I will go ahead and put the answer key for this up on Blackboard so you can compare your work to that. Nope, just for your own practice. Textbook homework. It's on your assignment sheet. And you can go and head on out to lunch, guys.